Okay, so here's what Archimedes did. So I'm just taking one of our equilateral triangles.
Yeah.
So you remember from the one that went on the inside, the circle was outside of it?
Yeah.
Okay, and the equilateral triangle that went outside it to make the hexagon just touched it right in the middle.
Yeah.
So Archimedes said, hey, instead of using equilateral triangles, maybe what I can do is cut each equilateral triangle side here in half, and I can make a new shape on the inside that's going to have 12 sides. And I'm going to be a little bit closer.
Yeah.
And then the one that goes on the outside, I'm going to do the same thing. Instead of these bulges that go out like that, maybe I'll make the bulges smaller and go this way.
Ooh.
You see that?
You can keep doing that.
So now I have a 12-sided shape on the inside,
Yeah.
if you can imagine that going all the way around.
Yeah.
And a 12-sided shape on the outside. And looks like it's going to be a better approximation for the circumference.
Yeah.
And it also looks like the one that goes outside is going to be slightly bigger, and the one that goes inside is going to be slightly smaller.
Yeah.
Right?
Cool.
So, and here's what Archimedes did, and I read this in my book last night, 100 Great Problems of Elementary Mathematics. This is a really cool book. So Archimedes said he found a formula. So I let A equal the big perimeter, and B equal the small one.
Yeah. Cool.
And every time I cut this in half, I get a new A. I'll call it A prime. The new perimeter on the outside. And B prime is the new perimeter on the inside.
Oh.
And he found them in terms of the old ones. So A prime, let me make sure I write this right, is 2 times A times B divided by A plus B. And B prime is the square root of B times A prime, the new one. Okay, now, believe it or not, this looks incredibly complicated, right?
Yeah.
But it's actually just the Pythagorean theorem again. But I don't want to go all the way through it. But Archimedes came up with this very interesting formula. Now, let's see if we can do this just for our 12-sided one. Remember, the big perimeter was 4 times the square root of 3 all the way around?
Yeah. 4 times the square root of 3.
And the small perimeter was 6.
Yeah.
Okay?
Yeah.
So for the new one, we're going to say, for the 12-sided one, we're going to get the big perimeter is 2 times 4 times the square root of 3 times 6. 2 times 4 times the square root of 3 times 6 divided by 4 times the square root of 3 plus 6. Whoa. Now, that's a very complicated number, right?
Yeah.
Okay, it's 8 times 6, which is 48.
48.
Times the square root of 3 over 4 times the square root of 3 plus 6. Now, do you know what that number is?
I don't think so.
Yeah, and it's tough because Archimedes didn't have an iPhone or a computer. They had very primitive tablets, but not the kind of tablets that you know about.
No.
So this was a tough number for Archimedes to think about, and then he could plug that into here and take 6 times this number and the square root of it and get a new b.
Yeah. Cool.
Okay, but luckily, we don't have to do this all by hand. We can write a computer program to do this.
Yeah.
Cool.
Okay, so do you guys want to go do that?
Yeah.
Sure.
All right, and then we'll see if we get better and better approximations to pi. Okay?
All right.
All right, let's go do that.